Okay, let's talk about going, the reverse of naming acids would be taking the name and writing a formula from that. Slightly different, not too bad. It's kind of reverse of the directions that we have for writing a formula, or excuse me, for naming an acid. Let's take it step by step. First thing we're going to do is we know it's an acid, so we're going to write down hydrogen as our first element. It's the first element in the formula. Second thing we're going to do is we're going to identify the anion from the root and ending in the acid name. You want to keep in mind, we'll note here, note the prefix hydro means no oxygen in the acid. It's just something to look for. If you're writing oxygen and you've got an acid name with hydro in it, you know that you've done something wrong. Next thing we're going to do is we're going to get, kind of like in the ionic formula writing, we're going to get the ions to add to 0. And then subscripts show the number of hydrogens needed to add to 0. All right, so let's go ahead and take a look at a couple of examples here. We'll go from a name to a formula. Now, I'm choosing stuff that we have memorized from the ion sheet. If you're still a little shaky on the memorization there, you probably want to review that for the test, because you've got to know these ions. It'll make life a lot easier because you're not going to have that ion sheet to use. But in the meantime, you can certainly look them up. So let's say we've got something like carbonic acid. So we said for our formula, we're going to write down hydrogen first because we know hydrogen is going to be the first element. So I'm just going to write down hydrogen. And I'm going to take a look at my ending and my root to decide, what that anion is. I'm trying to identify what's next. I take a look at the ic ending. Ic means that my anion must end in ate. So that leaves me with this root here. And what I could do is, I'm going to show you on the ion sheet. I go ahead and go to my list of common ions, and I go down, and I'm looking for something that ends into ate and has has carbon with it, and there it is. Let's see if I can get a highlighter here. There it is right there, the carbonate. Oops, that's not going to work. Okay, never mind. But there it is, carbonate ion. So carbonate was CO3. CO3 with a -2. We know hydrogen is always a +1. So I want these to add up to 0. This is the carbonate. Goes with the carbonate ion. So I got to get these to add up to 0. I need another hydrogen, H+. So altogether that gives me a formula of H2CO3. So that is carbonic acid. Let's go ahead and walk through another example. Let's take something like acetic acid. Again, I know it's going to start with hydrogen, so I'm going to go ahead and write down hydrogen. You know what, I'm just going to put plus on there right now because I know eventually I'm going to mess with the ions. Next thing I do is I take a look at my ending and my, again, ic tells me the anion must end in 8. So I'm looking for an ion that begins with ACET, acete, as its root, and ends in ATE. So I go to my list of common ions, and I'm looking for, there it is, the acetate ion, C2H3O2 negative. So that's the anion I'm going to use. It's the acetate ion. So C2H3O2 with a negative. They already add up to 0, and I get a formula for this acid of HC2H3O2. The other way to write this is this anion is actually can also be written as CH3COO negative. So that would give us HCH3COO. Both of those are acceptable for acetic acid. Let's try something that's got an exception to it. Let's say we've got phosphorus acid. Again, I know hydrogen is going to be the front end of this. So I'm looking at my roots. OUS tells me that this must end in ITE. This root here, phosphor, that is for any phosphorus-containing anion or phosphorus-containing acid. So I'm looking for something with phosphorus ending in ite. Not on this side, it's not one of the ones we had to memorize, but it is on my back side of my ion sheet. My reference side, there it is, phosphite is PO33 negative. So this is the phosphite ion. So that's PO3 3 negative. I need a grand total of 3 hydrogens to get this to add up to 0. I've got a +3 here plus a -3 here equals 0. So we get 3PO3 as the formula for phosphorus acid. It's a little bit of an exception because of the phosphorus, the phosphorus containing acid. Let's take a look at one more. Let's take a look at hydroiodic acid. Again, hydrogen is going to be the first ion there, H plus. Looking to identify some things. I've got two clues here. I've got ic and I've got hydro. These guys both kind of go together. This tells me that I've got no oxygens in the, oops, I misspelled oxygen. I'll go back and fix that in a second. No oxygens in the acid. So I'm looking for an ion with iodine, because here's my root, iode. So I'm looking for an ion that has iodine in it with no oxygen. Really, I'm looking for iodine, or the iodide ion, and that guy is right there. It's one of the ones we should have memorized. So I can go right to the iodide ion, which is going to be I minus, which means my formula is going to be HI, hydroiodic. And again, I'm looking and I got no oxygens in there. Hydro tells me I've got no oxygens. Kind of a double confirmation here. That's most likely the right answer.